thanks for stepping up with the talk after a late cancellation and putting together this talk on a short notice. This is also your first talk.
Yes.
Yeah. I think we should give him a very warm applause. And thank you.
Thank you, everyone. I'm happy to be here to talk about thinking in SQL with Django. How many of you here have used Django and didn't have a relational database? None of you. You used no SQL? All right, a couple. But the rest, who has used it with a relational database? All right. So the overwhelming majority. So that is why SQL. And to underline the importance of SQL, let's see where SQL came from. According to Wikipedia, it first appeared in 1974 here. And just maybe saying 1974 is not enough, but this is, for example, what Sony, when they advertised their tape deck in 1973, advertised as technology built to last. So just that should tell us how long SQL has survived. And if we see any job adverts for Django developers today, we usually see technologies like Docker, Kubernetes, and if it has a front-end element, we always see the latest kid on the front-end block. Some years ago, it was Backbone, JS, and jQuery. Now it's the newest guys are React.js, Vue.js, and yet SQL is always lurking there somewhere. It has been used since that time. And as Django developers, I think we have to pay attention to it. Another aspect of why SQL is worth knowing and worth kind of dealing with is this concept. I think it was popularized in Nassim Nicholas Taleb's book. It's called the Lindy Effect, and it's basically it originated by Broadway actors and performers meeting at this Lindy Cafe in New York City, and they arrived at this conclusion that if a show on Broadway has been performed for the last 50 days, then there's a good chance that it will be performing for the next 50 days. Similarly, if it has been performed for the last 100 days, to do the proof of concept for this talk, I have a GitHub repository. It is linked to from the talk on the Django Day Copenhagen website. There is the code and for this talk. While developing the code for profiling, which is step one, is I use these. Explain and query are built in to Django. You don't need to install anything to access those. Explain prints the query execution plan depending on your database. For example, this one is a sequential scan on this table, and that is from SQLite. If you access the query property of any query set, it shows you the SQL that will be evaluated, that will be executed when the query set is evaluated. Then I also used a couple of extra tools. One of them is Django Extensions, among which it provides this shell plus command, which when you pass --print -SQL to it, it prints any SQL that is executed around against the database when you're running the code. The last tool I use is the already mentioned here Django debug toolbar, and we'll see its use later on during this talk. So with profiling out of the way, let's go to the use case that this talk is about. And it's a very simple. It's the one is the relationship that the docs talk about. It's about pizza and toppings. So a pizza can have one or many toppings, and the topping can be on one or pizza. So it's a many-to-many relationship. To make it more interesting, we'll add the requirement wherein each topping can be vegetarian, vegan, or neither. And on the menu card, I want to see a V when the pizza is vegetarian and a VG when the pizza is vegan. How do we determine if a pizza is vegan or vegetarian? A pizza is vegan if all its toppings are vegan. So, for example, tomato sauce is vegan. Whereas a pizza is vegetarian if all its toppings are either vegan or vegetarian. So, for example, mozzarella is vegetarian. Ham, of course, is neither. So with those requirements, let's go to how we would model these. So in the first approach, you would have two Booleans. This is not really great because whenever you have this vegan set to true, you have to add the check constraint that it is vegetarian would be true as well. The second approach would have a choices field. So we would have a drop down in a UI, for example, and we are storing constants. Vegan is 0, vegetarian is 1, and we store rating in a way that null values means neither of those. And to compute whether a pizza is vegan or vegetarian, we use Python, the Python all function, and we loop over a condition based on the toppings. So if all, again, it's vegan, if all toppings are vegan, and it's vegetarian, if all toppings are either vegan or vegetarian. Whoa, all right. So back to the code. This is how we would render the menu card. This is the query set here, and this is the template. We loop over them, and we see vegan or vegetarian next to each pizza. The code to load this data is in the repository if you want to have a look. And yeah, this is the menu. So let's go back to where we started and think in SQL. What SQL is powering this screen, this render template? And here we have the Django debug toolbar. And as you can see, for the pizza, we have the first query, and then the rest of the pizzas are basically getting the topics to get the rating for the pizza. And we have a lot of repeated queries there. So it's known as the n+1 or 1+n situation, which there is a link in the references which you can read more about there. So how do we go about fixing it? We follow what Django's docs tell us and retrieve everything at once, since we know that we will need it. And to do that, we just add prefetch related, and now all toppings are prefetched in one query. So we have two queries. So over a large data set, that would result in a massive gain. The Django debug toolbar also shows us the exact query and data that is retrieved for our request. So very good. How do we ensure that we do not lose this gain? And the answer Django provides is in its test case assert num queries. So within this context here, we do the code, we run the code, and then we ensure that it never executes more than this amount, bypassing the amount of queries to assert num queries. So that's very good. So we are profiling. We are doing we are doing we are prefetching all data required in the minimum number of queries possible, and we are ensuring that we don't exceed that amount going forward. So what can we do? This is a result if you remove the prefetch related. This is how the task breaks. So how do we ensure? What can we do more than that? And in this case, we follow this suggestion here. We do database work in the database rather than in Python. So previously, we have on the pizza model, we have the is vegan and is vegetarian, which have a loop and it's looping over all toppings and then calling the all function to determine whether a pizza is vegan or vegetarian. But since vegan is a subset of vegetarian and vegetarian is a subset of all toppings, we can model this data differently, remove the null constraint, and it will be a straightforward migration because we change all values from null to 2. And then, rather than looping, we get the max rating of the toppings for a pizza's toppings. So that should be one query. This is how it looks like. So these will be removed. And now we are using another aspect of Django's ORM. We are now using annotate. We are using conditional expressions, case when, to determine is vegan at queries at level and is vegetarian at queries at level. Notice how using a manager results in dry, that is, do not repeat yourself. And we can also now access is vegan at queries at level. This makes a big difference if, for example, you're using Django REST framework and filter sets, because now you can order by or filter on those fields. The crux of this is that we have max rating, which is the maximum rating for a pizza, for a pizza's toppings, and it is accessed by the many-to-many relationship toppings here and its extended field here. So very good, all good, right? Let's see what SQL it generates. And the SQL is this. And yeah, I noticed that it might be too small there, but the big problem here is that it might not be a problem if the data set is small, but on large data sets. So let me ask you a question. Who here has been bitten by outer joins in SQL? All right, a handful, a handful, all right. But so for those who haven't been bitten by outer joins yet, when you have a large data set and you try to join table, which the query planner doesn't know how to join because there are no immediate keys between the two tables, then outer joins are done. And here in the explain, we see a hash aggregate. This is a PostgreSQL query plan, and the hash aggregate uses a temporary hash table to group records. It does not require a pre-sorted data set, and instead it uses large amounts of memory to materialize the intermediate result. And it's not pipelined. What that means, so to cut short, the effect of this is you would see your database instances CPU go to 100% and your site becoming unresponsive. And you will see HTTP 544 server timeout. So was this the thing we have done before? Was this a premature optimization? And let's get back to thinking in SQL. And it isn't, because this should be doable without left outer joins. How can we do it without left outer joins? This is what we think as a many-to-many relationship, but it does not exist in reality, because in reality we have an intermediate table for any many-to-many relationship, which in Django it's called the true table, THROUGH. So with that true table, since this true table, basically it has the pizza ID and the topping ID. So shouldn't it be possible to get the max topping here if we know the pizza ID here? And this, since the ID of the topping table is stored here, we do not really need a left outer join. We can do it via inner join. So to recap, where are we? We followed all Django's docs suggestions. But we ended up in a situation where the SQL generated by the ORM could be a performance issue. So now we are thinking back in SQL, not necessarily in Django, how to do this efficiently. And we want to use this relationship to get the inner join. And the tool I mentioned earlier, Manage PyShell, in this case, Manage PyShell Plus with Django extensions. The big benefit of using Python is that you can try the code and see the results immediately. And here, I am trying to get the max rating for a pizza using the true table. The true table is so pizza toppings is the many-to-many field, and the true table here accesses directly and allows you to make queries against the intermediate table directly. And this, in fact, returns the pizza toppings for our capricciosa here. And if I do an aggregate max rating on those toppings, we get 2. So notice that this, Paolo, your answer on Stack Overflow this morning was related to this query here. So how are we? So what does Django provide to be able to do this query and relate it to our outer query? And the answer is subqueries. And the Stack Overflow answer from Paolo this morning is documented here. Kind of someone asked earlier whether it's in the docs, and there is an example which is not identical but similar. It's here, and it's for the subquery class here, and another handy class that goes with the subquery class is the outer ref class, which refers to a key on the outer query. And in this case, it's the pizza ID, because we want to relate the query on pizza toppings, the intermediate table, with the outer query, which is querying pizza. So that's why here we use pizza ID. However, the first attempt never works. And in fact, I got an error. So I need to work it out differently. So again, thinking back in terms of data and SQL, if we order all results here, all toppings for the capricciosa, and we order them by descending order on rating, since based on our algorithm, and get the first one of that result, that will always have our max rating, because 0 is vegan, 1 is vegetarian, and 2 is neither vegan nor vegetarian. If we get the highest one, it's always pizza's rating. So if again, I tried to retrieve that, and this is the shell I was trying to arrive at a solution. If we get the latest, and we order by descending, so not the latest, sorry, we order by descending order on rating, and get the first one, we get 2, which is 2 is non-vegan, non-vegetarian for this case. And the resulting SQL, again, we don't see any left outer joins. It's an inner joins from the intermediate table here to the topping table. So again, can we just put this query in the subquery? And the answer in this case is yes, it works. So here we see the subquery, the conditionals are still here, is vegan and is vegetarian. Max rating uses the subquery, and it gets, and we see in the resulting SQL that there are no outer joins. So the results are all inner joins. And by profiling, we can see this is a Postgres-specific plan. This time, the hash aggregate is gone, and instead we have hash joins. Hash joins are much faster because they work with an intersection of the data. The data, it's using IDs, so it's pre-ordered. So it's the fastest way we can join data. Or at least, I'm not sure it's the fastest, but it's much faster than the other one. And this, it's from personal experience. This is what can bring the site back up. If we look at the changes, so let's say that the site was unresponsive because of this data retrieval issue, and the PR comes in. And notice how little changed. And even we didn't even need to change the tests, because the tests, while they were helpful in allowing me to arrive at a solution, they were checking for the correctness. That is, that I didn't break anything in how vegan and vegetarian are computed, and that the same amount of queries was being done. But while the same amount of queries is being done, this is much more efficient. And this brings me to the point of the talk, which is to be mindful about the SQL, because yes, the Django ORM makes it much easier to just write your Python code and not. I do this myself. I forget a lot of the time about the SQL it generates, and that's why I once brought the system, the site I was working on, down with a newly added left outer join. So what have we done during this? What have we gone through? And we did relational modeling, taking query into consideration. We used model managers to achieve do not repeat yourself in logic. So the logic we don't need to repeat D is vegetarian anywhere in the code base. It's just on the query set. We used a lot of Django good parts here, prefetch related, conditional expressions, the true table. We used assert-num queries. And together, all these, they give us, in my opinion, very, very fine-grained control over the SQL that is generated. We didn't need to use raw SQL at any point. And as mentioned by Paolo earlier this morning, raw SQL has its downsides. The docs go through them. If you want to read more, the docs, the Django docs, not the references of my talk. They allow us, these functions allow us to achieve dry and not repeat logic around the code base, and they allow us to test that logic. And if we already have a continuous integration pipeline that goes automatically, even though we're testing SQL, that goes automatically in with the rest of our unit tests. So the conclusion is, know your SQL. It's easier said than done. As I said, it's very easy to start writing. Django is the framework for perfectionists with deadlines. If you have the ORM tool, you just want to use it and get things done. After all, we are makers to make your thing. But it's very important to know your SQL because, as I discussed earlier, it has been the common a part of the tech stack for applications for decades now. So, yeah. These are the references for the talks about things that, due to time constraints, I wouldn't discuss as part of this talk. And for the future, I wish you 0 left outer joins and a lot of inner joins. So, thanks, Samil. Thanks, Benjamin, and thanks, Klaus. Where is he?
Yeah, thank you. Right on time.
Yeah.
Not according to the schedule, but we started 5 minutes
later,
later, so we have 5 minutes for questions. And you go first, audience. Way in the back.
Yeah, you mentioned one thing you said was this isn't going to break any tests when you fix that. What if I then want to test the break in case someone comes along later and says, "Why is this so complicated? We'll just do max and swap it back again." Is there a good way of testing to say we reverse it to hash aggregate? Or?
My God.
Okay, so
I don't have
the question is, can we test that people don't somehow like revert our optimizations? Other developers, I mean.
Unfortunately, I don't have an answer. I would put a comment, and that's I would put a comment. But yes, it looks complicated because it's a one-line change, and then it's several lines and the subquery. It's true. It's a very, very good question. There is no. I don't know of an easy way to guard against that, other than a comment, please, with caps. Exactly.
I'll add a note. Sometimes inner joins are also like horrible.
Yep.
If you have a few million rows in both sides, it just kills everything.
Yeah, but in this case, the specific one, it should speed things up.
Yeah.
Because
there is they added a new work clause on the inner left joins in Django, which is also super useful. So you can do filters on joins themselves.
Yep. I didn't have space to.
But you have a blog post
There is
with
a
all the
blog post, but it's not
examples?
necessarily on this. It's a basis for a part of this.
Yeah.
It evolved over because it's 2 years old.
A good way to get started with these concepts. The blog
Yes,
post and this
yes.
talk. Yeah.
Yeah, actually, the Django docs provide a very good job as well. But again, they don't go into this edge case kind of where you expect things to work, and you still need, if you want your SQL, in some cases you need to know your SQL.
Yes. There is a question there. There is two. Way in the back first.
The ORM has come on leaps and bounds over the years since its relatively humble beginnings, to the point where raw SQL is, as you say, a last resort. When would you find yourself wanting to make use of raw SQL at this point? Is there a threshold where you find it easier?
So the question is if there is a threshold that can guide you when it's easier to use raw SQL.
I would try to avoid it as much as possible. There are downsides, as Paolo mentioned earlier. There's the injection issue, and I think even though it can return as a query set, there are some aspects of it. It's not exactly the same. So the question is more a human and project specific answer. So if your project, you can't afford to spend 1 day trying to do this without resorting to raw SQL, then if you hit that time limit and you have the SQL, then you might just go with the SQL and add a ticket for the next iteration. You know how we work. We have deadlines, not unfortunately. Sometimes it's good to have deadlines, because then you might do optimization that is not worthwhile. So it's more of a human concern, and depending on your situation.
And there was another question in the back. Yeah.
Hi. I've noticed that newer developers don't really learn that much of SQL anymore, especially the people who are so used to ORMs. So they sort of like don't even realize maybe what all the SQL is doing. Do you have tips for people who have not learned SQL thanks to ORMs or whatever to get started on this?
Really good question about new developers that may not know SQL but use the ORM for the first time.
Yeah.
How can they learn SQL?
So yeah, as I mentioned, it's great to have Django provide us with the ORM because it speeds things up and makes things, the interface between Python code and the relational database, it makes it way better than if you're suddenly seeing SQL code embedded in your Python code. It's a bit of a cognitive dissonance. So I don't really have a suggestion. The fact that I've been coding for over 15 years, I did code store procedures in my initial. So that's how I know my SQL. So the way I learned it is because I had to. But if they, what do I suggest? It has to be out of interest, and maybe using Django with tools as the debug toolbar, and you can monitor the SQL that is being then in order to understand what the Django debug toolbar is printing on the screen, then you have to start understanding. And then when you see the different times, why does this query take 4 seconds and the other one takes less than a second? Then with those questions, you start investigating. But if you're working on a Django project, that's the only, you won't tell your boss, listen, I want 1 day I will be learning SQL rather than working on the project. It's not doable. And
someone mentioned earlier pair programming. That can be a really good case for pair programming, to sit down and look at
absolutely. And if you're in a team, that's a big benefit.
Yeah. There's there's competing hands. I'll try this one.
Just a quick comment. It's like for me, it helped a lot using like tools that are query plan analyzers, right? That explain the query plan to you, because it can be very daunting the first time you look at the output of explain analyze or something.
Yeah.
And there's those tools where you input it and it tells you exactly what these things are. Like they're just online if you look at the query. query plan.
Yeah, whenever I use a query plan analyzer, I end up Googling because I always forget what the terms mean. So hash aggregate, I put the definition there, even for myself as a presenter, to remember exactly what it is, so that I can explain it during the talk. So it's not, I don't know those things by heart, and probably no one does.
Yeah. So a tip to use query analyzers
and
to understand the SQL.
And to be okay with not understanding things all
Yeah.
the time.
So question there, Johannes.
Yeah, I was wondering, like, I've also seen the opposite case where people who come from a different background, like many years of SQL, they think in SQL, and so they go into Django and they like, know a little bit about the ORM, but saying, actually, I'll just throw some raw SQL in there. Really easy for me to understand, but really difficult for everybody else to understand. And isn't that like you have to have like a balance? Like, yeah, maybe you can make it 0.001 second faster, but you also eat up every other developer's time trying to understand your raw SQL that you throw in
Who will maintain it?
Yeah, exactly. And like, where do you put the balance?
So like same question as earlier, but the opposite way. Like if you're just coding in SQL, how can you find out that you should actually maybe switch to the ORM?
So just to add a bit of my own personal trajectory, I went from MySQL and a lot of stored procedures in Oracle. This was back in 2006, 2007, to Django. And it was my first time using an ORM. So at first, that's what I tried to do, what you mentioned, that is write SQL. Why do I need an ORM? It's slowing me down. Actually, it was SQL Alchemy at the time, because it was in Django, it was TurboGers. It was another Python web framework at the time, before I started using Django. So yeah, I felt like it was hindering me. And I understand that, but the project, if it's a Django project, this is a Django conference, we write Django most of the time. And nowadays, the prevalence is that people write Django. So you don't want SQL, and as I mentioned, you want to write tests for all the code you write, because you want to test also the clauses that you write, even though in terms of coverage, one test will cover all cases, but ideally you build with the Django packages like Factory Boy and Baker. It's very easy to build data and then ensure that the logic in your queries works for that data. And so the answer is kind of you have to migrate you have to mind shift. I don't know if it's the right term. From writing everything in SQL to this is a Django application, I will use what Django provides. And as I've shown in this talk, Django provides the ORM is very feature complete, in my opinion.
There is time for one more question, which is from this gentleman here.
Yes. Sometimes the Django team are not the owner of the SQL. For instance, there's a business division with the data maintainers, and they'll kind of set out how to use the databases. Would you give your thoughts on that?
So your thoughts on database maintainers in the role of the like expanded use of the ORM?
Yes, when the Django project is not the owner of the database.
Yeah. So the case here, if I will repeat so that I make sure that we understand each other. We have a data team and we have a web or applications team. So the applications team is doing Django and the data team owns the database. So they have to talk to each other because the code, the application team will generate the SQL that is run. And no matter how many indexes you make, if something is suboptimal, the indexes become a suboptimal solution. You might, because I saw a lot of in working, you see a lot of approaches like caching at different levels and also a lot of indexes, which sometimes are overkill. When your SQL could be written, the original statement without any bells and whistles can be simplified or made to work more efficiently. So the idea here is, whether you have a data team or not, is to make sure that the SQL is the most efficient. In that case, yeah, they have to talk to each other and define who is responsible at the end of the day, because if both of them are not responsible or if both of them are responsible, which means none of them are.
Maybe we can initiate that conversation with them and not wait for them.
Exactly,
they're
that's
probably
that's an
angry when
idea.
they
Yeah, we
call us.
as the Django part, right?
Yeah. So we don't have
Good
time
question,
for we don't have time for any more questions because we have a cake break. I think it is ready. Water break. Water break, not cake break. There's an